Okay, so now let's work a couple of examples together from section 1.2. So in this first example here we have a diagram showing a plane, showing a couple lines. It does look like here that this one line is actually passing through the plane. If you look real close here, let me point this out to you. Part of that line here is actually dashed. And so what they're showing you there by that dashed line is that that part is underneath or behind that plane. So this plane is actually over top that you can't see behind it, so you can't see that line going through. That's just kind of the book's way of showing you kind of what's going on, helping you see the diagram properly. So example A, what are two other ways to name line QT? Well, line QT is that line I was just talking about. There's point Q, there's point T, so it is this vertical line, or that line going up and down, not quite vertical, going through that plane. Well, we have another point down here, N. We could name this line NQ. We could name it line TN. Okay, and there are other ways we could name that. There is this M sitting down here. Notice N is capitalized, so N is that point. M is lowercase, so N is talking about the line. So I could just say, hey, I'm talking about line M. All right, part B, what are two other ways to name plane P? Well, again, looking at this plane here, and again, that does extend on forever in all directions, even though we only see this little part of it here. P is that capital letter there, no point next to it, so they're talking about the plane. To name a plane, I need to use points then. And I need to use 3 points, but they cannot be on the same line. They cannot be collinear. And so R, Q, and S are all on the same line, so I cannot use those 3 points to name my plane. But if I put point V into the mix, I could then get plane RVQ, that would work, or I could say plane VQS, that would work, and of course there's other combinations of those points that I could use, but point V has to be in there because that is the one that is non-collinear. Part C, what are the names of 3 collinear points? Well, I kind of already answered that in my description for naming the plane. That's points R, Q, and S. R, Q, and S are collinear points. And then they ask, what are 4 coplanar points? Well, points that are on the same plane, I could talk about point R, Q, and S. Not only are they on the same line, but they're also on the same plane. But I can also then talk about point V now, because point V is still on that same plane of plane P. Alright, so please pause the video at this time, go into Class Kick, and try the example there. Alright, well in this example, this is number 8 from your homework. It says, what are 2 other ways to name line EF? So line EF is this line right there. And when I look at that, I see, hey, there's a little N sitting out in front of that line. So I bet that's one way to name it. So I could say N, or I could even say, line N. You'll see that done a lot. Later on in this class, we'll name it just like that. We'll get rid of the word line. So line N, that's one way of naming this. Another way, we have point B is also on that line. So I could say BF, line BF. And of course there are other ways. I could say line EB. I could say line FE. I could say line BE. Just kind of turning these things around. Oops, not BH. Don't know where that came from. BE. Okay, so there's lots of different options. Of course, you only need to name 2 other ways. All right, this is an example that's not in your class kick, but I would like you to follow along. What are the names of the segments in the figure? Well, looking at this diagram, I see that we have a line, and on that line they name 3 points. So a line segment, well, that is going to be the part between two endpoints. So I could say that I have line segment DE. I could also say I have line segment DF. And I could talk about line segment EF. Okay, so those are the 3 distinct line segments in the diagram. Of course, I could name them differently. I could, instead of naming it DE, I could name it ED, but it's really still the same line segment. So those are all the line segments shown in the diagram. Part B says, what are the names of the rays in the figure? Now here you got to be careful because rays, direction matters. Okay, so if I start at point D and go this direction, that is one ray, and I could name it ray DF. Okay, but that is a distinct ray. If I name it ray DE, it's still the same ray. It's still starting at D, passing through those points. So DE and DF are the exact same ray. Let's try another one here. What if I start at E and pass through F? Well, there's only one way to name that one, and that's ray EF. What if we go the other direction? What if I start at F and go this way? Well, that would then be ray FE. Now again, that ray, I could have called it ray FD. It's the same ray. Ray FE and ray FD are the exact same ray. Doesn't matter which way you name it. And what if I start at E and then go this direction? That would then be ray ED. Okay, so we then have 4 distinct rays in this diagram. All right, part C, which of the rays in part B are opposite rays? Well, for rays to be opposite rays, they have to have the same endpoint, but together form a straight line. So the shared endpoint in this case is going to be E. That is the endpoint. And so then going in one direction, that gives us ray EF. Going in the other direction gives us ray ED. And together, they form that entire line. So it is ray EF and ray ED. All right, please go back to your class kick. I have, I believe, one more example for you there. So in this example, it says to name the rays in the figure. So again, there are lots of rays we can name here. I like to just start at one point. So let's start at the end point R. If I start at R and start going in this direction, there are 3 different ways I could name this ray. I could say ray RS, ray RT, ray RW, but those are all the exact same ray. So I'm just going to go ahead and call it ray RW. If I start then at endpoint S and go in that same direction, I then have ray ST or ray SW. Again, they're the same ray. So I'm just going to go ahead and call it ray SW. I can start at endpoint T. So all right, well T, going in the same direction, TW, there's only one way to name that one. All right, but those are 3 distinct, 3 different rays. If we start going in the other direction, we can again start back here at W and now go this way. Now again, this first ray can be named 3 different ways. Ray WT, ray WS, ray WR. They are all the exact same ray, so you have to just pick a way to name it. So I'm going to go ahead and name it ray WR. One thing to keep in mind here, notice the order in which you name them matters for rays. Ray RW was a very different ray than ray WR. Why? Because they have different endpoints and they go in different directions. Ray WR is heading kind of up and to the left, whereas ray RW is heading down and to the right. Okay, well, if we start at endpoint T and head in that direction, we have TS or TR. Again, they are the exact same ray, just two different ways of naming it. And then if I start at S and head in that direction, I then get ray SR. So again, in this diagram, there are 4 different rays. Okay, did you show your work? Did you do your examples in Class Kick? If so, make sure you check your answers and then you can move on to the homework.